In this discussion video, we'll do a practice problem where we find limits graphically. So this is problem number 5 from worksheet 2, and we have this graph. Okay, and I want to evaluate the following limits. So I'm going to zoom it out a little bit so we can see all parts of this question. So we have A up until part J, a bunch of these limits. And I want to give you 4 minutes to try this question on your own first. So 4, 3, 2, 1, pause the video for 4 minutes to try all parts of this question. It should be pretty quick once we get the hang of it. Alrighty, so hopefully you did that. I'm going to zoom it back in. So if you haven't finished trying it, pause the video and make sure you do that. I'm going to zoom it back in now so I can take a better look at this, and let's start talking about these. So part A says, well, what's the limit as x approaches 6 with this little plus sign? And remember, that little plus sign means from the right. From the right. And when I see a minus sign of the exponent, that means from the left. From the left. Okay, so let's do part A. What is the limit as x approaches 6 from the right of our function? So that means we're going to be looking at our function on the right side of 6. So that is this part of the graph on the right side of 6. And I'm getting super close to where x is 6. And the limit, when it asks us what the limit is, it's asking, well, what are the y values? What do the outputs get really close to? And on that side of 6, the y values are getting super close to 5. Okay, so the limit equals 5. Now let's do B. What is the limit as x approaches 6 from the left-hand side? So now we're going to be approaching 6 from the left-hand side and getting really close to 6. That's this part of the graph over here. And as that happens, remember, with a limit, we don't care what's happening exactly at the number. So we don't care what's happening exactly at 6. Because exactly at 6, we have a point up here, but we don't care about where that point is exactly. We don't care where the point is exactly at 6, I mean. Okay, so from the left-hand side of 6 again, as I get really close to 6 from the left, the y values get super close to this hole, and that hole's y value is at 2. So that's my limit from the left. Alrighty, now we can do part C. This is asking for an overall limit as x approaches 6. Sometimes I call these two-sided limits. And as x approaches 6, this limit does not exist, D and E. And it does not exist since the one-sided limits are different. I'll say the one-sided, I'll abbreviate limbs, are different. And I'll abbreviate different, are diff. Okay, I can think about this kind of more conceptually as x gets really close to 6, the y values, my function is approaching two numbers. It's approaching 5 from one direction and 2 from the other direction. And that can't happen. The limit, the y values need to approach just one finite number for the limit to exist. Alrighty, let's do part D. This is now asking, what's the limit as x approaches -8 from the right? So as I approach -8 from the right, that is this part of the graph. And as that happens, the y values are getting super close to the y value of the whole, which is -6. Remember again that we don't care what's happening right at -8. Because right at -8, we have a point here, but we don't care about that point when we talk about a limit. A limit just means we get super close to -8, but we don't actually equal -8. Now let's do E. What's the limit as you approach -8 from the left? Well, that is this part of the graph. And again, the y values are getting close to the y value of the whole, which is -6. -6. So now F, what's the overall limit as x approaches -8? Well, because the one-sided limits are the same, that's what this overall limit is. It is -6. -6 since the one-sided limits, the one-sided limbs are equal. All right, let's do part G now. G is asking, what is the limit as x approaches -2 from the right-hand side? Okay, let's go up to the graph a little bit. So -2 from the right-hand side. So here's -2. The right-hand side of it is this part of the graph, getting really, really close to where x is -2. And as it happens, the y-values are getting huge, really, really huge. So this limit is infinity. H is asking what's the limit as x approaches -2 from the left. And as I approach -2 from the left, that is this part of the graph getting super, super close to -2. And there the y-values are approaching 3. So I asks me to put those together. What is the overall limit as x approaches -2? And this is going to be d and e for the same reason as c, since the one-sided limits are different. Since the one-sided limits are different. All right. There's one thing that I forgot to comment about g, but let me go back and do that now. Remember, g was asking what's the limit as x approaches -2 from the right, and we said that was infinity. Because as we got super, super close to -2, the y values got huge. Technically, because this is not a finite number, we wrote infinity. Technically, this means this is a does not exist limit, d and e. But remember, we've said when the limit is infinite. So if it does not exist because it's some sort of infinite thing going on, then we need to specify if it's positive infinity or if it's negative infinity. All right, so one final part of this example, one final part of this example, which is j. What's the limit as x approaches 10 now of my function? So let's go up to the graph. And this is not a one-sided limit. It's kind of an overall limit, a two-sided limit. And as we get super, super close to 10 from the left, and as I get close to 10 from the right, the y values get really close to 0. And that is this limit.